Excellent. So for the first one, my y-intercept is going to be -4. What else? Good. The slope is 3/1. How'd you know that, Gabby? Very good. It's in y equals mx plus b form. We also call that slope-intercept form. What do I do with that information, Gabby?
You go down 4 on the y and -4.
Mm-hmm.
And then you go up 3 into the right one.
Perfect. Gabby said we go to -4 on the y-axis, and then we go up 3 to the right one, and then we draw a line going through those. So we graphed the first one. Was anyone able to figure out how to graph the second one? Daniel, what'd you do?
Well, first I subtracted 2x.
Very good. Why? Why'd you do that?
So because it's in standard form, but I need to get it to slope-intercept form.
Good. After you did that, what'd you get?
I got -2x plus 12.
Okay.
And then I divided by 4, the whole thing.
Mm-hmm.
And then I got -1/2 x plus 3.
Excellent. But how did you get that?
Oh, because you can't have the x after the y-intercept, so you put the slope first,
Mm-hmm.
-2x,
Mm-hmm.
and then since it's not -12, you can't just put 12, so you have to put plus 12.
Good.
And that's how that's also the standard that's also how you convert standard to slope-intercept.
Good. And my favorite part, Daniel, is that you distributed that 4. You put the 4 underneath the -2 and underneath the 12. So -2 divided by 4 is going to simplify to -1/2, and then 12 divided by 4 is going to simplify to 3. From here, what's my y-intercept, guys?
3.
3. What's my slope?
-1/2.
-1/2. Perfect. So I'm going to start at 3, and I'm going to go down 1 to the right 2. Down 1 to the right 2. Do you guys see where these graphs intersect? What point do they intersect? 2, 2, 2. Okay? That is essentially all we're doing today, is we are going to have 2 different equations, right? We're going to be asked, okay, what is what's called the solution? And the solution to these 2 equations is wherever they both meet up. So 2, 2, is that the only solution? Are these graphs going to intersect at any other point? No. Okay? They're only going to intersect at that point because the red graph is going to continue off in this direction, but they've already intersected. The blue graph will never intersect it at any other point. Okay? System of equations is more than one equation. It can be 2 or more, and they need to have the same variables, okay? So just like the warm-up that we just did, that was considered a system because there were 2 equations, okay? Now, the solution of a system of equations with 2 variables, it's going to be an ordered pair. So normally when we think about a solution, we think about like x equals 7, y equals 9, okay? We solve for one of the variables. For a solution for a system of equations, your answer is going to be an ordered pair, okay? So it's going to be x comma y, all right? The first part of this lesson is we need to be able to check our solutions, okay? So for each of these examples, we're given a system of equations, of 2 equations, and we're given a coordinate pair, or a coordinate point, okay? Which is 2, 5 in the first example, okay? In order to check whether it's a solution or not, you have to plug in the x value, plug in the y value to both equations, and it needs to satisfy both. If it doesn't satisfy either one, it's not a solution. If it satisfies both, it's a solution, okay? So let's check it out. For the first example, for A, okay, my first equation is x plus y equals 7. I'm just going to write that down here, x plus y equals 7. And I'm going to plug in the values, x equals 2 and y equals 5. And I got those from the coordinate point. So plug in x equals 2, so I'm going to get 2 plus y is now 5. And I'm going to see if that equals 7. 2 plus 5 is 7, so 7 equals 7. Does this one work? Yes. Okay. I'm going to do the same thing, but for the second equation. So 2x minus 3y equals -11. So we've got 2, plug in 2 for x, 2 times 2 minus 3, plug in 5 for y, equals negative 11. 2 times 2 is 4. 3 times 5 is 15. And we're going to see if adding them together will give me negative 11. 4 minus 15 is going to give me negative 11, and that equals negative 11. So we're Gucci. If they both work, we say 2 comma 5 is a solution. So guys, essentially all I'm doing is I'm plugging in the values of my coordinate into both equations, not just one. Okay, you have to plug them into both. And if it works for both, we've got a solution. Okay. Now, I want you guys to relate this to the warm-up. Do you see how the point that we found, the intersection point, 2 comma 2, it was part of both lines? It goes through the blue line and it goes through the red line. Okay. That is what we just found. We found a solution, okay? We found the point where both of those lines are going to intersect. Questions so far? Okay, let's do B. So in B, our point changes to negative 2 comma 0. So my x value is negative 2, and my y value is? Y is 0. So I'm going to take the first equation, which is y equals negative 2x minus 4, and I'm going to plug in. So I've got y, which is now 0, equals negative 2 times, plug in x, which is negative 2, minus 4. I'm going to get 0 equals negative 2 times negative 2 should be positive 4 minus 4. So 0 equals 0. Does this work? Yes. Can we say it's a solution? Not yet. Why not? We have to do the other one, okay? So underline your other one, and we're going to plug in 0 for y, so 0 equals, our x value is negative 2, so negative 2 plus 4. And what's negative 2 plus 4, guys? Positive 2. Are 0 and 2 equal? So this one did not work. So do you see how it satisfied the red equation, but it did not satisfy the blue equation? Is this a solution? Not a solution. Okay? Now, let's go back to the warm-up really quick, okay? And let's see how this particular scenario compares to what we just did on the warm-up, okay? So what we found was the point, negative 2 comma 0, it worked for the red equation, but it didn't work for the blue one. Do you guys agree?
Yeah.
Okay? So, if we picked the point 1 comma negative 1, does that point work for the red equation? Is the red line going to go through that point? No. So it doesn't work for red, but does it work for the blue?
Yeah.
So this would be an example where if we were to plug 1 comma negative 1 into the blue equation, it would work. But if we plugged it into the red one, it wouldn't work. Do you guys see that? Okay. Now, if you picked a point over here, would this work for either equation? No. Okay. If it doesn't lie on either line, it's not going to work for the red or the blue. Okay. But if it only lies on one of the lines, it's going to work for one of them, but not the other. And if it lies where they intersect, then it's going to work for both. Yeah. Sure. Okay. So let's check it out. Let's check out C and D. What do I do for C? Daniel.
You plug in, first you have the x and y, which is 1, negative 2, so you plug in the first one, 2 times 1 is 2, plus y, which is negative 2, so 2 plus negative 2 equals 0. So the first one's correct. And then on the second one,
Okay.
you do the same thing, so negative 1, so you plug it in, plus 2 times negative 2, which is negative 4, so just negative 1 plus -4, which is, and -5 does not equal 5, so that one's incorrect.
Good. We ended up getting -5 equals +5. This is not true. So Daniel, what can we say about this point?
Not a solution.
It's not a solution. Sophia, what's up?
Did you have to put it in slope-intercept form or no? You
No.
just leave it in standard form?
So if we were asked to graph this, okay, then we might want to turn it into slope-intercept form. But this is just checking, okay?
Okay.
So for these problems, we just need to plug in and figure out whether it's a solution or not. Okay? Great question. Great question. All right. Are we cool on C? All right, who's feeling comfortable with this and wants to try D? Bruno, go.
Okay, so it's gonna be 4 equals 3 plus 1 for the first one, because 3 equals 1 and dx,
Okay.
and y is 0. And then the second one's gonna be 4 equals -1 plus 5, because when you distribute the 4 out to y, it's 1,
Uh-huh. So what do we get? 4 equals?
4,
Yep.
4 equals -1 plus 5.
Yep.
So yeah, they're all both checks, and that's the solution.
Very good. So this one is a solution. Okay. So you must check for both equations. And if it works for one, doesn't work for the other, not a solution. If it doesn't work for either, not a solution. If it works for both, we've got our solution, okay? That is where both the lines will intersect. Could you think of a scenario where there would be no solution? Think about graphically. What would need to happen for there to be absolutely no solution? Bruno?
The lines don't intersect.
Yeah, very good. The lines would not intersect. What kind of lines would we have if they don't intersect? Parallel lines, okay? So if your slope is ever the same, you're never going to have a solution. When would you have infinitely many solutions? Yeah,
And the lines are on top of each other.
very good. If they were the exact same line, when the lines are on top of each other, because they would intersect at every single point, okay? Now, we're not going to talk about those in this lesson, but we are going to talk about them later on, so keep that in the back of your mind. All right, so we're able to check solutions. The next
-5.
section is we need to solve the systems of linear equations by graphing. So we're no longer given the point. We're going to be given the two equations, and we're going to be asked, okay, you figure out the point by graphing each of the equations and locating the point where they intersect, okay?
Oh, you just have to find the point they intersect.
Yeah, exactly,
Do
okay?
we have to say if it's a solution or not?
Absolutely.
All right.
Okay.
We find the point they intersect.
Started. How am I going to graph y equals -2x plus 5? Isa.
You put a plot at +5 on the y-axis
Very good. Why?
because 5 is the y-intercept.
Bingo. 5 is my y-intercept. Keep going.
And then you have to go, so since it's negative, the slope is -2 over 1.
Mm-hmm.
Which is, so you go down 2 and then to the right 1.
Excellent.
And then you go again down 2 to the right 1.
Perfect. I'm going to go up 2 to the left 1 just so I have some on both sides. Perfect. All right. Someone walk me through the second one. Shayla.
Your slope is 4 over 1.
Perfect.
Your y-intercept is -1.
Excellent.
So you start at -1 on the graph.
Mm-hmm.
You go up 4 to the right 1. And you go upstairs to the right 1. And you put a line through it.
Very nice. Do we see where these two graphs intersect? Janessa?
They intersect at 1,3.
Excellent. 1, 3. Okay. So we're halfway there. We eyeballed it to figure out where they intersect, so we need to check that both equations work for that point, 1, 3. So that's where what we did on the previous examples, that's where that was super important. So we need to plug in where x is 1 and y is 3 and see if it works for both equations, okay? So let's check it out for the blue equation. We're going to plug in, okay, so y is 3 equals negative 2 times 1 plus 5. Cody? What's that? Yes, you need to check it, okay? Okay, so then we got 3 equals negative 2 times 1 is negative 2 plus 5. We're going to get 3 equals 3. It works. Let's check out the red one, okay? Same thing. Y equals 4x minus 1. 3 equals 4 times 1 minus 1. 3 equals 4 minus 1. 3 equals 3. That one works as well. Okay? Now, the reason we're checking it, again, is because we eyeballed it to figure out where they meet, right? We're graphing them to the best of our abilities, but we're kind of making an estimate as to where they intersect. When we check, we make sure for certain that they intersect at that point. So now we know for a fact that 1, 3 is our intersection point. That's our solution. How many solutions does this system of equations have? Just one, okay? Because they only intersect at one point. All right, if you're like completely Gucci with all of this, I want you to do B, C, and D on your own. If you need one more exercise, I'm going to do B with you guys, and then I'm going to set you free to do C and D, okay? All right, so let's do B. In B, my first equation is y equals x minus 2. That means that my y-intercept is what? Negative 2. My slope is what? Positive 1 over 1. Excellent. Okay? So I'm going to start at negative 2. And what am I going to do from there? If my slope is 1 over 1. Gabby? Excellent. Up 1 to the right one, up 1 to the right one, up 1 to the right one, or down 1 to the left one. Okay? Got a bunch of points. Let's draw a line going through all of them. Ooh, that was not what I wanted to do. And then our second equation is y equals negative x plus 4, where my y-intercept is 4. My slope is negative 1 over 1. So I'm going to start at 4, and I'm going to go down 1 to the right one, down 1 to the right one, down 1 to the right one. And I'm going to draw a line going through those. Do you guys see where they meet up? 3, 1. But we're not done, okay? We have to check for each of them, okay? So over on the side, you're going to say, okay, well, x is going to be equal to 3, y is going to be equal to 1, and check each of them. So for the green one, we're going to get 1 equals 3 minus 2, so 1 equals 1. Beautiful. That one works. For the red one, we're going to get 1 equals negative 3 plus 4. This is just 1 equals negative 3 plus 4, which is going to be 1 equals 1. That one also works. So 3, 1 is our solution. Yep.
So when you get 3, 1, you flip.
Thank you, Zach. Zach, how do I do it?
Start off at positive 3
Why?
because that's the y-intercept,
Excellent. Start off at 3 because that's the y-intercept.
and then the slope is 1 up and 2 to the right,
Excellent.
and then you do the opposite.
Mm-hmm.
And then for the next one, you start off at negative 5
Okay. Why?
because that's the y-intercept.
Good. Keep going.
And then the slope is negative 0 over 2, so you go down 3 and left 2.
Yep. Down 3 to the left 2. So this way.
No, not the other way.
Oh. So what do I do? Down 3
Yeah, and
to the right 2.
right 2.
There you go. But that's going to take us further away from the other line, right?
You're gonna do opposite.
So let's go up 3 and then
Left.
perfect. Up 3 to the left 2. Do you guys see where they're going to intersect?
Yes.
What point is that?
-4, 1.
-4, 1, baby. -4, 1. Am I done?
No, can I do the next one?
Go ahead, Janessa.
Okay, so then you're gonna replace y for 1 and replace x for -4.
Mm-hmm.
You're gonna have 1 equals 1/2 times -4 plus 3.
Yep.
That gives you 1 equals -2 plus 3, and then -2 plus 3 is 1, so 1 equals 1.
Booyah. So it worked for the first one.
And then the second one is you're gonna put 1 for y and -4 for x, and you're gonna have 1 equals -3/2 times -4 minus 5.
Mm-hmm.
When you multiply -3/2 times -4, you're gonna get 6. So then 1 equals 6 minus 5, and 6 minus 5 is 1, so 1 equals 1.
Beautiful. Zach and Janessa. Excellent job, guys. Okay, so moving on to D. This one was a little bit trickier. Why was this one harder?
Because it wasn't in slope intercept.
It was not in slope intercept form. I tried to trick you guys, but I didn't trick all of you. Did anyone get it?
I do.
Veronica, walk me through it.
When you convert the first one to slope intercept form, it's y equals -2x plus 5.
Excellent.
And then you graph that, so you put 5 on the y-axis.
Mm-hmm.
And then you go down to the right one,
Mm-hmm.
and then you keep doing that.
Yep.
And then for the second one, when you put it in slope intercept, it is y equals 3/2x minus 2.
-2. Beautiful. Okay. How did you get that though? Let's walk through those steps.
When you subtract -3,
Not just 3.
-3x,
-3x. Yep.
and then you get y equals, -2y equals -3x plus
Mm-hmm.
4.
Yep.
And then you divide by -2 on both sides.
Perfect.
And you get y equals 3/2x minus
That's how we got that. Okay. So our y-intercept is -2. What's my slope? 3/2. So up 3 to the right 2. Up 3 to the right 2. We should have gotten a line that looks like this. What's the intersection point? Shayla? 2, 1. We're done? No. Okay. What do we have to do? Check it every single time. Okay. So we're going to plug it into the original. Okay. Why do you think I plug it into the original?
Check.
Yeah, because what if I made a mistake when I was moving x over, right, and solving for y? I want to be able to figure that out, so I plug it into the original, not what I used for graphing it, okay? So let's plug it into the original. We have 2x plus y equals 5. Plug in x is 2, so 2 times 2 plus the y is 1 equals 5. 2 times 2 is 4. You add 1 to that, you get 5. Beautiful, okay? So the blue one works. Let's check the red one. 3x minus 2y equals 4. Plug in 2 for x and 1 for y. 3 times 2 minus 2 times 1 equals 4. 6 minus 4 equals 4. That's not 4. That should be what? 6 minus 2. And we get 4 equals 4. Gucci Marucci. Questions? Okay, peeps. Why do you have to check your answer in both equations?
To find if there's a solution.
Very good. You need to check the exact solution. Because when we're eyeballing it, right, we could be off by a little bit. But in order to figure out if it's exactly the point that we think it is, that's why we have to check it. We have to plug it back in. And should we trust that just looking at the graph will be the answer? No. Okay? If you don't check it, will you lose points on your test? Yes. Okay? Is this stuff going to be on the midterm? No. Okay? Chapter 5 is not on the midterm. Sorry, guys. I know you guys are really hyped because this is easy. Okay? It's not on the midterm. Okay? We've got one more challenge problem. Okay? It's not that bad, though. Go down to B.
Mr. Jurko,
Yes.
I have a question about this.
Of 18 math and science exercises for homework, you have 6 more math exercises than science exercises. How many exercises do you have in each subject? Okay? What do you guys think I should start by doing? What?
I put,
You did?
wait, start off by doing?
Yeah, what do you think we should do?
Write an equation.
Write an equation. Very good. So we need to write an equation. What do you need to write an equation? Cody?
I have a question.
Yeah.
So, let's just say I know the answer already. Do we have to do all that stuff?
No, because I know a bunch of people already know that it's 12 and 6, okay? But you need to graph it, okay? And you would have no idea what to do to graph it in order to solve this, okay? So that's why we're doing this together. What do you need in order to write an equation, guys?
Numbers,
And
variables.
variables, okay? So we need to find an x and a y, okay? Now, are there 2 things that we don't know in this problem?
No. Or yes.
What don't we know in this problem? What are we trying to figure out?
The slope and the line.
Nope. What are we trying to figure out? Specifically from this word problem. Gabby?
How many exercises are in math and science?
Ah, we need the exercises in math and science. So X, I'm just going to represent math exercises.
I have a question.
So then what would Y be?
Science exercise.
Science exercises.
So you plug it in as in like 12x plus 6y equals 18.
Hold on.
Confused.
Yeah.
How do we know, like, for a test, how do we know to put math exercises in X and science exercises in Y?
You could have mixed them up. You could have put Y to be math exercises and
But
X to
wouldn't
be...
our graph be different?
No, yeah, it would be a little bit different. But they would intersect at the same coordinate, right? Because your X and Y would just be different values. So at the end, we're going to get X comma Y, and it's going to be something comma something. You would just reverse it, right? Okay, so we need to write 2 equations in order to solve this problem, okay? Let's take a look at just the first sentence. You have a total of 18 math and science exercises for homework. What equation could represent that sentence? Daniel?
X plus y equals 18.
Perfect. X plus Y equals 18. The number of math exercises plus the number of science exercises needs to be equal to 18. The second part of the equation says you have 6 more math exercises than science exercises. Who thinks they know an equation that could compare those 2? Daniel?
12x plus 6y equals 18.
No. 12x plus 6y equals 18.
Wait,
So we don't know that they're 12 and 6 yet. Just use what's written in the sentence. You have 6 more math exercises than science exercises.
so what if you subtract, no.
Oh, you're on the right track.
What
Subtract
if you
what?
subtract 18 from 6
No.
or 12?
No plan. 6
minus
18.
Let's use x and y, guys. Remember, we need an equation with x and
Oh,
y.
you would subtract 18
Minus y.
minus
Hold on.
X or Y.
Does 18 have to do with the second sentence?
Mm-hmm.
No.
Does the second sentence say anything about 18?
Oh, it's 6.
It's 6, okay? Subtract 6 from what?
From X or Y.
X.
From X.
So we should do x minus 6 is going to be what? If we take the math exercises and we subtract 6 of them, what do we get?
Y.
Y, the science ones, right? You could have also written x equals y plus 6, okay? Either of those would have been fine. Cody, are you okay? All right. Okay, so we've got 2 equations. we need to now solve them by graphing them, okay? So we're going to find out where they intersect. Is the first one in slope-intercept form?
No.
Can we change it? How?
You subtract x from 18.
Very good. So you just write y equals negative x plus 18. You subtracted x from both sides. The second one, is it in slope-intercept form? No, but it kind of is, right? You just have to rewrite it as y equals x minus 6. Put the y on the left and the other part on the right. Okay, how do we graph these? Daniel?
Well, the first one, you start off by, you go to, there is no plus 18, so you just do it a little bit up, and then you can just do the math later. Above 12. And then put the slope in, like, negative x. So, like, go to, on the y-axis.
I don't know what's happening, guys. Okay. So you said go to 18 on the y-axis.
Although there is none, so just go a little bit above 12.
So I'm gonna change these y values so that we can go up to 18. So let's count by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So it intersects at 18, right? So put a dot at 18. And what was my slope of the first one? -1, right? So we're going to go down one to the right one, down one to the right one, down one to the right one. And it's going to keep going down, 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 down. Okay. The other one, make sure that if you counted by twos in the positive direction, you have to count by twos in the negative. So -2, -4, -6, -8, -10. And our second graph has a y-intercept of -6. And it goes up one to the right one, up one to the right one, with a slope of +1. And where do they intersect?